As far as day 5 is concerned, Jaslyn, what's the topic going to be today? Yeah, point slope form. Now, wait a minute. We talked about another form. Ben, what was that other form we dealt with? What was that form we've been dealing with these last couple days? Something like that. Oh, isn't that, what do we call that? Slope. Isn't that slope-intercept form? Yeah. And guys, what's useful about slope-intercept form? What are the two things it can give us about a line? Let's ask that question. What's useful? What does it give us if something's written in slope-intercept form? What can we pull from that equation? Well, we can pull one point. What point is that in particular? You get the y-intercept. And Jazz, remind us, what is a y-intercept? That's where our line crosses the y-axis. Yep. So B, we know slope-intercept form, it gives us where the line crosses the y-axis. What else does it give us? It's in the name. It gives you the slope. Yeah, the name actually gives away what it gives you. It gives us the slope too. And really, Shelby, aren't those the only two things you need to make a line? A point and a slope? Because once you have a point, you can rise over run to get the rest. Here's the problem though, guys. What happens if we don't know the y-intercept? Makes it kind of tough. Makes it tough to use slope-intercept form. Here's where point-slope form comes in. We're going to be able to write and graph equations just like we've been doing, but now if they're in point-slope form. Look at that. Look at the name. Ben, what are the two words you see in this form?
Point slope.
Oh, that's kind of like slope-intercept.
Yeah.
Except guess what? This point could be any point on the line. This is where this form gets useful. Point-slope form, we can create an equation using any point on the line. It doesn't have to be the y-intercept, like with slope-intercept. We can pick a random point on the line. Any point on the line. What other word, Jaslyn? What other word do you see in here, though? Slope. Hey, this still gives us our slope. That's kind of nice. So guess what? We still have M. We still got our slope. So we know the rise over run. Now this equation is going to scare some people. But let's do a quick reminder. What's a point made up of?
2.
2? The number 2?
Yeah.
No. What do we know points are made up of?
X and Y.
X and Y. In fact, what do we usually call the first point?
X1, Y1.
Yeah, that's what we're going to have here, guys. We're going to have a point that is x1, y1. It's our first point. It's got an x. It's got a y. Those are its coordinates. We've got m. And what do you notice we had in slope-intercept form? What always stayed the same? We would change m and b, but what didn't change, Ben? Y and x. Guess what? All of this is going to be true. We're still going to have a y. We're still going to have an x. Check out what this looks like, guys. Y minus, what's the y coordinate? What do we call that? Is that y1? Equals, here's where your slope's going to come in. Slope, m, times x. Wait, does somebody remember this? Sarah, Ben, x? No, wait a minute. Well, there's no b. That's slope-intercept form. What were the two things we had with point slope? We have an m, x1, y1. So if this was y minus y1.
X1
Yeah. X minus x1, yeah. So you keep the x's with the x, the y's with the y. So you've got y minus our y coordinate equals our slope times x minus our x coordinate. And remember, guys, y1 and x1 are a point. These just come from the point that we know on our line. If you know the slope and you know a point on your line, you can make point slope. It's a little bit of a longer equation, isn't it? It looks a little longer. There's more to it. It's not just a b and an m.
I thought it
Well, no, what is x2? That's if you're trying to find the slope. We're assuming we already have the slope. This is, oh, they gave us a point, so we can put the x and y coordinate in. Check this out. Let's see what this looks like, guys. Let's do an example. We got a line that passes through the given points. Boom. That point right there. And has the given slope. That slope right there. So, Jasmine, what's going to be our x1 and y1 in number 1? Uh-huh. Yes, ma'am. And guys, let's just plug these in. Shelby, help us out here. It'll be y.
-3.
Yep.
Equals m.
What do we know our slope is? 5.
In parentheses, it would be x minus 1.
Hey. Nice word, Shelby. Y minus your y coordinate equals your slope. And then x minus your x coordinate. We'll do one more together, and then I'm going to let you guys try one. Anybody want to take a shot on number 2?
Sure.
Hey, I like that, Ben. Go ahead.
X under 2 and
That-
y under 2.
That's our x1, y1, isn't it? That's the first point they give us. So go ahead, Ben. What are you thinking for our equation?
Y equals
Now, wait a minute. It won't be equals, will it? Isn't it y minus y1? So y minus -1 equals, what's our slope? What? -3. Parentheses.
X minus,
Yeah, in this case, x1 is, okay. So y minus y1 equals m times x minus
I don't know
x1.
why I thought so hard on this.
Here you go. Hey, and Jazz, is there maybe a way we could clean this up a little bit? What happens if you have some double negatives? Oh yeah, let's rewrite this a little bit easier. Make this look a lot nicer. Y plus 1,
That made me so confused.
yeah, equals -3. I know, you're probably like, why is he putting 2 negatives?
Yeah, I was
We
like,
never
isn't
do
that
that.
supposed to be positive?
I
That's what
wouldn't-
I put, and I thought it was wrong, so I erased it.
Yeah, you're good. So check it out. If you have negative coordinates, that's going to cause a double negative. So it becomes a plus. So I'm going to let you guys try number 3 for me. Do that. So Jazz, what's our x1 and y1 on number 3? 4 -7. That's our first point they give us. And so what would our equation look like? Ooh, why is that a plus? Yep. Y minus -7, double negative becomes a plus, equals. X minus 4. Yep, x1's a positive 4, so when you plug it in, that stays negative. We don't have a double negative situation. Nice job on that, Jess. Shouts out to you. Coming at you.
Okay, she got a mint.
She,
Volunteer.
she helped me out on number 3. I said that'd be a myth question. Now, here's where I'm a little worried. Because this, in the past, this part's confused people a little bit. What happens when they give you the equation and you now need to pull a point and a slope out of that so you can graph the line?
Jesus Christ.
Remember what we talked about? In order to graph a line, you need a point and you need a slope to create the other points. What's the easy part we can pull out of number 4? What's the slope going to be, Jess? Yeah, the slope's going to be 3. That was easy. Will that maybe be 3/1? Yeah, for our purposes. Right, because we're going to want to use a little rise over run action. Great job on that, Jaslyn. Here's the tricky part. Oh, you want to see if you got this one too? Let's go. Yep. Oh my goodness. What a beast. Yes, ma'am.
Wouldn't that be -2?
It would not be, because isn't it originally, that's a good question, Shelby. Isn't it originally x minus x1?
Yeah.
When is the only time that would become a plus? If